Hello everyone, welcome to my dental talk, and today I'm here to give a small details of the topic hypothesis in the statistics topic which we face problems. And okay, let's go into the topic. Yes. So, what is hypothesis? Hypothesis is basically it's a principal instrument in the research and methodology subject. It is a principal instrument. And what's its function? Its function is mainly like we suggest new experiments and new observations in the research. So that is the main function of this hypothesis. And next, hypothesis is like in understanding in a simpler words, it's just an assumption or a supposition which is to be proved. It should be proved. That statement it should be proved. Okay. So coming to the definition, so I would like to dictate the definition. So if you want to write, you can note it down, or otherwise you can follow with the definition. Right? It's a proposition. Okay, you're proposing a statement. It's a proposition or a set of propositions with which you have to explain. You have to explain the. I'm sorry. You have to explain the occurrence of some specified group of phenomena, either like the asserted or as a provisional conjecture. And these asserted phenomena or the conjecture phenomena will guide to the investigation, or they will be accepted as a highly probable in light of established facts. Okay, now I would like to read the whole definition. A proposition or a set of propositions um, set forth as an explanation for the occurrence of some specified group of phenomena, either asserted merely as a provisional conjecture to guide some investigation, or accepted as highly probable in light of established facts. Okay, next, coming to the characteristics, which is a very important thing in hypothesis. So let's come to the first thing. First one is that it should be clear. It should be clear and precise. If your hypothesis is not clear, then the results are not reliable. Fine. Next, the second one is it should be capable of testing. Right? It should be capable of testing. And the third is relationship. You just remember the word relationship. So what happens here is it should state the relationship between the variables. I would give no, I'm sorry. Okay. So it should state the relationship. So what is this variables and the relationship? For example, in an easier word, let's take oral cancer. 1 minute. Oral cancer. Okay, and the smoking and the alcohol consumption. So these are the three variables, and the hypothesis it should be framed in such a way that let's say that there can be an increase in the occurrence of oral cancer with the consumption of smoking and alcohol. So here there are three variables, and you're showing the relationship between these three variables in a hypothetical statement. So the hypothetical statement should give the relationship between the variables if it happens to be a relational hypothesis. Again, okay. Next thing is that it should be limited and specific, right? it should be limited and specific. The hypothetical statement, it should not be too long, and either it should not be too non-specific, like it should not contain too many confused statements. Okay, and then it should be simpler in words. Okay, it should be very simple. It should be an understandable language, and it should be simple, right? And next, consistent with the known facts, right? Consistent. The sixth point is that it should be consistent. So what is the consistent with the known facts is that it should be accepted easily. With the statement should be accepted easily. It should not contain any tough words or any words, or it should not show the meaning which is too difficult to understand. And then the seventh one is that it should be amenable to testing within a reasonable time. Remember the word reasonable. Reasonable. So what is this reasonable time? Like it should have a specified time. So in some X years or in some X months. But because if you not go with the reasonable time, you cannot test a experiment, right? You cannot spend your lifetime on testing it. And then the last but not the least characteristic of hypothesis is that uh, it should give rise to the need for explanation. So why are you proposing that statement? It should explain. It should in fact explain the problem. It should deduce the original problem, right? So these are the characteristics of the hypothesis. Next, we come to the null and specific hypothesis, right? A null and alternative hypothesis. I'm sorry. So, what are this null and alternative hypothesis? Suppose, let's say that minute. I'll just go with the color. Yeah. Suppose you have taken an experiment X, and you want to see whether what type of result it's going to give. So, to deduce the result, you follow a method A and a method B, right? Now, if suppose the method A and the method B both are equally superior, and that is you cannot differentiate between the quality of the two methods, and the result obtained is it's appropriate, okay, it's accurate, then this will be said to be, and the hypothetical statement stating that these two methods are equal in giving a result, then you will state it as null hypothesis, right? It's said to be null hypothesis, um, which can be represented by H naught. Okay, and suppose other than equal, that is, if the result is not equal, when will it not be equal? When whether A is greater than B or when A is less than B, right? So this time it is said to be the alternative hypothesis. And remember, null hypothesis is always a specific hypothesis. You cannot give any approximate values in null hypothesis. Okay. Suppose let's take a population mean. So what you represent a population mean with mu, and a hypothetical mean with mu h naught. Okay. So in terms of null hypothesis, you say that h naught mu h naught is equal to mu, and in case of non-specific or alternative hypothesis, you say that mu is less than or greater than mu h naught. Fine. So this is null and alternative hypothesis. So next we'll go to the most important thing, that is the level of significance. So first thing is that it's a very, very important concept, right? Wait a minute. Mm, yeah, blank. Okay, it's a very, very important topic. Mm, fine. So another thing we have to remember is that this level of significance is always expressed in percentages. Remember, it's always expressed in percentages. Okay. Now I'll tell you another thing, that is simple hypothesis and composite hypothesis, right? In the previous slide, I've told you about specific and non-specific. So here you can see that the null hypothesis, where mu is equal to mu h naught, is the simple hypothesis, and the other alternative is said to be the composite or non-specific hypothesis. Okay. Now, for example, let us take that the level of significance to be 5%. Okay, so we have taken it as 5%. Now, what happens? What is this 5% showing here? Okay, for this 5%, it means that the researcher or the experimenter is willing to take 5% risk, okay, in rejecting the null hypothesis. He's taking 5% risk in rejecting the null hypothesis when it happens to be true. Okay, the level of significance of 5% is showing that the experimenter or the researcher is willing to take this 5% as risk of rejecting this null hypothesis when it is coming true. Okay, so I would make it more clear that it is the maximum value. Okay, it's the maximum value of probability of rejecting this null hypothesis, and when it is true, okay, it's to be determined in advance before testing the hypothesis. You have to take this level of significance in advance before testing the hypothesis. Fine. Okay, now let's move on to errors in hypothesis. We have come across these errors in hypothesis. Fine. Okay, there are mainly two types of errors in this hypothesis. One is type 1 and the other one is type 2. I'll make it clear for you. Type 1 is when your null hypothesis is true, but you have rejected it, which shouldn't have been done. Okay, it is true, but you have rejected it. That which should not occur. Okay. The type 2 is your null hypothesis is false. Okay, it is false, but you have accepted it. That is type 2 error. You understand? Rejecting what is true is type 1. Accepting what is false is type 2. And this type 1 error is represented as alpha. This type 2 error is represented as beta. And this type 1 error or alpha is said to be the level of significance of test. Level of significance of test. Okay, remember, type 1 error is called level of significance of test, and this is to be determined in advance. Suppose let us take that if type 1 error is fixed to 5%. Okay, it is fixed to 5%, and that means that among 100 there are 5 chances of rejecting the null hypothesis, right? This means that if the level of significance is 5% or the type 1 error is 5%, that means that among the 100 there are 5 chances of rejecting the null hypothesis. Okay, so how can we correct this? By fixing the value less than 5. Okay, that is, you can take for example to be 1%. Okay, and next let's go to the last topic of this session, that is two-tailed and one-tailed tests. Okay, we are really confused with what these tests are, right? So I've come with two graphs here, you can see. So first this graph represents the two-tailed graph and this represents the one-tailed graph. You can see here the shaded region, right? This and this and this. These are said to be the tails of the graph. Okay, these are said to be the tails of the graph. Oh, yeah, sorry. Now, in this graph, if we observe, we can see the shaded portion, which is if we consider the whole graph area to be 1. Okay, the whole graph area to be 1, we have 0.025 of each side to be under shaded region, and there is only 0.95 or 95% of the area is in the unshaded region, which is called acceptance region. Okay, and the remaining shaded is called as the rejection region. Fine, and I'm sorry, and this is the rejected region. So in the two-tailed test, what we have to do is, in this generally when we take the 5% as the significance level of significance, this represents the 0.05, right? 0.05 area. So 0.05 area is said to be under the rejected region. Fine. Okay, so you have to reject the null hypothesis if you have to reject the null hypothesis when it falls under this 0.05 area. Fine. When it comes under the 95% area, then you have to accept the null hypothesis. This is according to two-tailed test. And coming to one-tailed test, it is a single region of 0.05 area of a single side. Okay, and it can be on the left side or it can be on the right side depending on the situation. Okay, and the remaining 95% is under the acceptance region. Okay, thank you guys, and if you have any doubts in the topic, you can mail me immediately or you can comment in the sections below, and I've tried my level best to explain this topic. If at all I have missed anywhere, you can immediately post it, and the coming session will deal with the different tests and illustrations. Thank you.